Thank you, Quinn, from UNESCO for giving this opportunity to highlight IWMI's insights in artificial intelligence for water management, but more towards water extreme examples we would like to highlight. But I also must say a highlight in the upfront that it's a learning curve for us when it comes to use of artificial intelligence. We have been always working with government partners, extension, farmers, and community. We can certainly accelerate the growth of AI, which is, the examples that were presented in the previous session. So what we are building is more on what is the bottom-up coordination is coming from the relevance and the process that we would like to work more from the local government perspective. And that's where some of these innovations have been going to be presented for you here. So from our understanding, I think the presentations from private sector or from more on the utility side that was presented by K Water or from other organization here, we looked at specifically on optimizing irrigation. There was also a previous presenter has spoken more on irrigation and identifying the water resource potential. Here we are looking more into enhancing early warning and the focus of flood management. You will see some of the examples what we would like to highlight in the series of that. I think what we learn from the organization perspective is that I think everyone is in the space of AI growth, and because that is something where it can connect the dots of all the new data sets that's coming, but also a lot of documents that the policymakers and the government have prepared. They're all available in static process. And we want to bring that into a more digital and dynamic so that AI can certainly enable that mechanisms to leverage modern data, the policymaker, the what we call the citizen science information can play an important role. So we do see that investment is really important to upfront on what the growth of AI would look like. And secondly, on the support, why do we need to do that? It's mainly to build the local capacity, because there is always the biggest bottleneck is the governance part. When it comes to disaster, if you go to the commercial sector, you don't really face any coordination problem. Only in climate change impact, we always face problem of who to share the data, when to share, how they can use the data. There is always the support. The local government is really interested in that. And I think we have already started recognizing that the AI is getting embedded in various forms, whether it is in smartphone, whether it is in approvals, whether it is on utility sector. And I think what we are realizing is that there is a clear need of how water resilient infrastructure will bring more financing strategies at the country level, because at the end of the day, the governments at the different scale of sectors and institutions lack the finance part. And AI from water management can certainly augment that capacity and skill. And I think the forum like this here is specifically fostering how we have various open data. Yesterday there was a discussion on open hydrology, where we talked about the 6 principles of open AI principles. I think we need to bring that not just from the private sector, but more specifically in the public sector as we go forward. So these are some examples we just want to highlight, because I'm not spending a lot of time around how we develop this. This is in collaboration with Microsoft. Again, we are focusing more in the Southern Africa called Copilot, Water Copilot. And this is more of a co-design process with the government. And what you can see on the right side is the applications we are focusing on. It's not that we have achieved everything, but we have done quite a bit of work on water resource monitoring, the water quality work with the Limpopo Basin. What you see on the left side is the kind of a user requirement that we have reached it. They would like to have quick alert. They would like to have multiple user persona. The information that we share doesn't mean that they solve the problem of everything. We have different user, different content is required for different user, and the feedback capability is what we are trying to work as we go forward. So this is in partnership with Microsoft. So we are already scaling up this tool in number of river basins. We can happy to touch base with the colleague that is leading in IWMI. The other example is the digital twin. We have recently handed over to the government in the Limpopo Basin. It's again the newly established water commission in Limpopo. This is again a 3D dive of what this model system is, what we are demonstrating here. We did a lot of code design. As I said, the code design is very, very critical to say how the digital twin they would like to take it forward. So as you see here, we brought in the digital Earth Africa. I'm not sure how many of you know. It's a data gap that we are trying to fill through Earth observation data. It's a large strategic program built by the African Union, Digital Earth Africa, and we are bringing products from various part of public data assets like WAPOR, from the ECMWF, the CHIPS high resolution data that's made available recently. All these data sets are made use of how AI can certainly power, specifically like a chatbot tool we are developing. So you do have different personas sitting on the digital Earth Africa tool, I mean the digital twin product. And what is more important is the water quality monitoring is very, very successful for them. So they use the chatbot to monitor in the upstream. So there are some local community level water level measurement tools are made available in this tool. The other part I am just going to highlight, which we are also going to present and launch, where Monique is here, is about how we present this in the AI for Geo for Good Cement. This is called the Sukha Rakshak AI. It's basically the development that we have done for the government of India. The unique part of this tool is it's fully built on the government data sets. So we have forecasting skills coming from the Indian Meteorological Department, the NOAA, GFS forecast, the ECMF static products. Then we have the dynamic 7 to 10 days of data cube that we have constructed for the weather and seasonal forecast. What you see on the right side is basically the farmer, the local government, and the extension officer prepared a plan called the drought contingency plan. And these plans have been made available for entire country at a district level. And the plans are roughly about 60 pages. And if you are an officer, you want to go and prepare the drought contingency plan for the next 3 weeks based on the forecast skill, it's not possible for anybody to really learn and read what need to be done. So we brought in everything into a generative AI, and the agentic AI model has been set up by bringing different vectors like the presentation that was presented by Deltares. And now what we have is an AI assistant tool is being developed. And the good part of that, it also connects with 22 language models, the native language models produced by the government of India called Bharat AI. So at the end of the day, it is a government have to own this product. We bring in the government-led process and institutionalize this entire mechanism in collaboration with the Indian Council of Agriculture Research. I think I have one last slide, which is very, very important here. Because of limited time, I'm not touching upon all the innovations we are working in the country, in Africa, in Asia. What you see here is on the left side is a farm level advisory program and AI tool called GeoGovia, built for Sri Lanka. The second middle one is more for adaptation tracking tool, which is again developed for National Planning Department under the Ministry of Finance in Sri Lanka. The last one is early warning to early action and anticipatory action tool called Aware Platform. Each of those ministries and department are quite different, and they were quite silo in terms of collaboration. Now, what is happening with the AI is that we are able to bring all those partners in a single stack. The reason being is that one, you look at the extension sitting with the 1.69 million farmers, the paddy farmers are sitting here. On the middle part, the policymakers are thinking where the vulnerability levels are there, what investments we need to do. The third one is addressing the climate shocks. So you are able to bring a public sector, private sector, community organization. The main crucial part we need to still focus is the data interoperability, the coordination framework, and how do we really look at evidence building process at a national level. So in a national level for Sri Lanka, we have all these are nationally recognized platform. If that is not been done, we cannot just as an institution cannot say we have many platform, how we are going to coordinate. So I would leave that, thinking here, and we are really looking for more support and collaboration. If you have any further advancement in technology, we'll be happy to collaborate with you. Thank you.